All right, so last week you guys know we were dealing with monomials. Okay, we talked about adding and subtracting monomials, combining the like terms. We talked about the product rule. With the product rule, what do you do with your exponents? Add them. We also talked about the power rule with monomials. What do you do with your exponents there? Multiply. Okay, and then today we're going to look at dividing monomials. Okay, so we're just really adding to what we've already got as far as our rules. Combining like terms, multiply the exponents, the product rule, or excuse me, add the exponents with the product rule, and our power rule where we multiply those exponents, okay? Well, today we're looking at the quotient rule, which you guys know quotient is right opposite of multiplication, or the product, okay? So if you're looking at the quotient rule, guys, what that tells us is that anytime you have a monomial divided by another monomial, what you will do with those exponents is you will subtract them. So that would be the top exponent, or the first one, subtracted from the second one. Okay? All right, so if we're looking at a couple examples here, I'm going to zoom in real quick. Looking at number one, we've got x to the fifth over x to the third. If we were going to simply divide those, x to the fifth divided by x to the third, again, we'd simply subtract my exponents, and that would be x to the second. Okay? All right, looking at number two, we got k to the 12th divided by k squared. That would simply end up being k to the 10th. Okay? All right. Now, looking here, m to the third divided by m to the third, that's going to leave you with m to the, what's 3 minus 3? 0. Now, we're going to add to this just a little bit, okay? What do you get anytime you divide something by the same thing? 1. So what do you guys think? If you have m to the third divided by m to the third, that's the same thing, right? What could you also say about m to the 0? It would also equal 1. Okay? Anything raised to the 0 power is 1. It doesn't matter what the number is, what the value is. None of that matters. Any value raised to the power of 0 will always be 1. Okay? All right. Looking at number 4. Here we're looking where we've got multiple variables with multiple exponents. Okay, but we're still going to say that's the same, and we'll subtract the exponents of our terms that are alike. Okay? So we have a to the 6th divided by a squared. That's going to leave me with a to the what? 4th. And then we've got b to the 4th divided by b to the 3rd. That's going to leave me with b to the 1. Or you can simply just say the same concept would be a to the 4th b, because anything to the first power is just a base number that we have. Okay? All right, so looking here at number 5, we've got p to the 7th, q 16th divided by p to the 4th, q 12th. That's going to leave me with p to the 3rd and q to the 4th. Everybody good there? All right, here, number 6. Okay? X to the 20th, y 9, z squared divided by x to the 5th, y to the 9th, and z. So that's going to leave me with x to the what? 15th. All right. Y to the 9th divided by y to the 9th. It's going to be 1, or simply, it can't just be y, okay, because y is going to be a number, okay? So we're going to end up just leaving that blank, and then z squared minus z is going to leave me with just what? Just z, or whatever that number is, z to the 1. Okay? All right. Now we're going to look at situations where we have coefficients, or the numbers that we're multiplying by. Okay? Now, the first thing it says, divide the coefficients. Okay? We are going to divide the coefficients if they divide evenly. Okay? But we're also going to add just a little bit to this. So with your text box, we're going to add. So one, we're going to divide the coefficients if they divide evenly. Okay? Or we are going to reduce the fractions. Okay? we're going to reduce the fractions. Because if we end up with a situation where you have a value, how many of you guys know where you have a fraction and it turns it into this big, long, crazy decimal? Have y'all ever dealt with that before? Yeah. Okay, well, instead of putting that big, long, crazy decimal into our answer, okay, we're just going to leave it in the fraction in reduced form. Okay? So looking at and then the last thing, of course, which we always know, the last thing is always simplify, okay? But we'll do that with the quotient rule, okay? All right. So looking here at number 7, 6x to the 4th divided by 2x to the 3rd. We're going to divide the coefficients. So 6 divided by 2 is 3. And then we have x to the 1, or x to the 1, or we can leave that as 3x. Okay, because remember, anything to the first power is just the number that you have. Okay, all right, looking at 14. Or not 14, number 8, 14r squared s squared divided by 7rs. Okay, so here 14 divided by 7 is going to be 2. R2 divided by r is going to leave me with just r. And then S2 divided by S is going to leave me with S. We good there? All right. Number 9. Negative 36c squared d to the 5th divided by 4c squared d third. Negative 36 divided by 4 is going to leave me with what? Negative 9. C squared minus c squared leaves me with nothing, correct? All right. And then d to the 5th divided by d to the 3rd leaves me with d what? To the 2, or d squared. Okay. All right, looking here at number 10, guys, it's not anything different. We're just going to look at this one real quick. I feel like you guys can divide negative 15 by negative 3. Would I be correct? I feel like you can do the x to the 6th, x to the 5th, y to the 5th, and y to the 3rd. But look at that z. If you don't have anything on bottom to divide by, there's nothing to divide the z by, so you leave it just like it is and you'll bring it down. Okay? It's just like subtracting 0. Okay? All right, but now 11 is one of these where we talked about divide the coefficients. Okay? But I also like to add in there reduce the fractions. So here, guys, what is 4 over 8 reduced to? 1/2. So we're going to leave that as a half. And then n to the 5th minus n is going to leave me into the what? N to the 5th divided by n is going to leave me with n to the 4th. Okay? It's just like subtracting 1. All right, number 12. 12 is another one of those that I was telling you earlier. It may give you one of those crazy decimals. So if you guys have your calculator or you want to pull one up, okay, you start looking at that, 36 divided by 54, what does that give you? It's going to give you 2/3 as a fraction, right? But if you were going to do decimal form, it'd give you one of those long repeating decimals. So that's why we want to leave it as 2/3. Okay? So then we've got 2/3 m to the 9th divided by m to the 3rd is going to leave me with m to the 6th and n to the 3rd. All right, so moving along here, guys, and looking at 13, this is a combination of multiple rules. Okay, like I just told y'all, we're going to do some things that are a little untraditional, but it's just for visual sake. Okay, so operations that you have here, guys, you have your power rule, and you have your quotient rule here with number 13. Okay, so in order of operations, which comes first? Exponents or division? Exponents. Okay, so I want you to take your drawing tool, increase the stroke size, don't care what color you use. Okay, but my exponent is up top, so I want you to focus on the top, and I want you just to blank out the bottom. Okay, just cover up the bottom, because all I want you to focus on is the exponent at top, and then we'll come back to and look at the quotient rule. Okay, all right, so here, thinking back to what we looked at last week, 3x to the 5th, all of that squared. Everything inside the parentheses is squared, so you've got 3 squared. What is 3 squared? 9. Thank you. Good. And that's going to be 9x to the 10th, because remember, with your power rule, you multiply your exponents. Okay? All right, now I'm going to come back to my drawing tool, decrease the thickness, draw me a line for my division sign. Okay? Now, use your eraser tool and erase what's on the bottom there. Okay? Now you can visually see what we're going to be working on next. So then we have 27x to the third. Okay? Now, I did that simply so you can just focus on the power rule up top, and then you can come back and now let's work on the quotient rule. Okay? All right, so quotient rule, the first thing we're going to do here is reduce the fractions. 9 over 27 is going to reduce to what? 1 what? 1/3. Good. And then x to the 10th divided by x to the 3rd is going to leave us with x to the 7th. Are we good there? All right. Coming along over here, back to 14. Okay, looking at 14. Same concept here. Okay? We have the power rule along with the quotient rule. Okay? So the first thing that I want you to do here is take your tool and blank out the bottom. I don't want us worrying about that just yet. Okay? Now I want us to focus on simplifying or reducing the top with the power rule. Okay? All right, what is 2 to the power of 3? 2 times 2 is 4 times 2 again is 8. Okay? Then we're going to have a to the 6th. Good. And we'll have b to the 12th. Good. All right, back to my line tool. Good. Call my line under there. Let's me reduce it or simplify it. Good. Now we can focus on the bottom, and we have put what we have remaining, which is 4a to the 3rd and b to the 7th. All right, now finishing up, we've got 8 divided by 4, which is going to be 2. A to the 6th divided by a to the 4th, or excuse me, a to the 3rd is going to leave me with a to the 3rd. B to the 12th divided by b to the 7th is going to leave me with b to the 5th. All right, everybody good there? All right, right now we are not going to finish anything on this. Okay, you're going to come down to your homework, and everything that I have highlighted, you don't have to highlight it, but everything that I have highlighted, which is 1 through 12, that's what you guys are going to work on.